Something is happening in our solar system right now, and no one can explain it. A massive, fast-moving object, unlike anything we've ever recorded, is slicing past the sun at impossible speeds. It shouldn't be here. It shouldn't be moving like this. And the deeper scientists look, the stranger it gets. They call it 3I Atlas, our third confirmed interstellar visitor. But what it's doing, and what it's made of, defies everything we thought we knew. To understand what's really happening with 3I Atlas right now, we first need to understand what this object actually is, how it entered our solar system, and why its behavior is unlike anything astronomers have ever seen. Because even before it disappeared behind the sun, 3I Atlas was already rewriting the rules. We first detected this strange visitor months ago using the Atlas Survey System, a global network of telescopes designed to scan the night sky for potential threats. At first, astronomers assumed it was just another asteroid, a small rock drifting across the solar system like countless others. But within hours, that assumption collapsed, because this object wasn't just moving, it was moving too fast. Everything in our solar system is locked in an endless gravitational dance around the sun. Planets, moons, asteroids, they all orbit because the sun's gravity holds them in place. And the closer something is to the sun, the faster it must travel to avoid falling inward. Earth moves at 30 kilometers per second. Mercury, roasted by the sun, whips around at 48 kilometers per second. But this new object, this so-called asteroid, was moving at 58 kilometers per second, and it wasn't anywhere near the inner solar system. It was still beyond the orbit of Jupiter, more than 4 astronomical units from the sun. At that distance, nothing should be moving that fast unless it came from outside the solar system entirely. And that's when astronomers realized what they were looking at. This wasn't an asteroid, this wasn't a comet, this was an interstellar traveler, the third ever detected. That's where the name 3I Atlas comes from. Third interstellar object discovered by the Atlas Survey. The first was Oumuamua, famous for its bizarre shape and even stranger behavior. The second was Borisov, a textbook comet from another star system. And now, 3I Atlas, bigger, faster, and coming from a direction that made scientists freeze. Most objects that enter our solar system from beyond arrive from above or below the ecliptic plane, the thin disc-shaped zone where the planets orbit. Oumuamua came from above, Borisov from a diagonal path, but 3I Atlas came in almost perfectly aligned with the planetary disk, a near-perfect side impact trajectory. Astronomers called it a cosmic T-bone collision. It hit the solar system's plane with a tilt of only 3 degrees, an almost impossible coincidence considering the vast three-dimensional emptiness of space. And the direction it came from? The galactic core, the dense ancient heart of the Milky Way, home to some of the oldest stars in our galaxy. A region where worlds can survive undisturbed for billions of years. If 3I Atlas truly originated there, it could be twice as old as Earth. And as it approached the sun, something even stranger began to happen. 3I Atlas started behaving like a comet, but at a distance where comets shouldn't even wake up. Something inside it was stirring early, far too early. And that was the first clue that 3I Atlas isn't just fast, it's fundamentally different. As astronomers continued tracking 3I Atlas on its approach to the inner solar system, they expected the object to behave like a typical comet, silent, frozen, and inert until it crossed the 3 AU mark, where sunlight becomes strong enough to heat water ice and trigger sublimation. That's the normal pattern. That's what comets do. But 3I Atlas didn't follow the rules, because long before it reached that distance, it woke up. When researchers examined early observations from the TESS Space Telescope, images captured between May and June, they found something shocking. The object had brightened far more than expected. If it were a normal comet, the brightness, or flux, should have increased by a modest factor as it drifted slightly closer to the sun. But the data showed a 5-fold increase. That meant something was already boiling off its surface, something that wasn't water. This was the first major clue that 3I Atlas was not a typical comet at all. When the coma, the cloud of gas and dust that forms around a heating comet, was analyzed in detail, astronomers discovered it was dominated by carbon dioxide, not water vapor. The ratio of CO2 to water was nearly 8-to-1, the complete opposite of what we find in comets native to our solar system. Most local comets are built primarily from water ice, with smaller amounts of CO2 mixed in. But here, CO2 was the main ingredient. This explains why 3I Atlas turned on so early. CO2 ice sublimates at much lower temperatures, even at 5+ astronomical units, where sunlight is little more than a faint glow. CO2 can escape into space, but the surprises didn't end there. When astronomers looked at how the coma scattered sunlight, that is, the polarization of light, they found something that quite literally had never been recorded before. Most objects in the solar system show positive polarization, scattering light sideways. Even the previous interstellar comet, Borisov, followed the rule. 3I Atlas did the opposite. It exhibited extreme negative polarization, scattering light backward in the same direction it came from. And not just slightly negative, the most extreme negative polarization ever measured from any object in space. This told scientists two things. 1. The dust around 3I Atlas is unlike any dust we've ever seen. 2. Whatever star system it came from had very different chemistry and geological processes. Then came another mystery, one even stranger. Spectral analysis revealed that the coma contained nickel, but no iron. That's not normal. Nickel and iron are forged together in the hearts of dying stars, released in supernova explosions, and almost always found as a pair in comets, asteroids, and planets. Seeing nickel without iron raised an unnerving question. What separated them? Was it an exotic formation process, a violent impact, a rare chemical environment, or something even more unusual? Some mechanism we haven't yet discovered. And while scientists were still debating that question, another surprise appeared. By late September, as 3I Atlas passed the orbit of Mars, the object suddenly began releasing massive amounts of water vapor, far more than any comet should produce at that distance. This wasn't a gentle increase, it was a surge, as if something inside the object fractured, melted, or suddenly erupted. It was behaving like a normal comet, but only after behaving like a completely abnormal one. And the mysteries kept piling up. When its first tail appeared, astronomers noticed something almost comical, if it hadn't been so strange. The tail was pointing in the wrong direction. Instead of flowing away from the sun, it was initially facing toward it. That shouldn't happen. The solar wind always pushes tails outward. Yet for 3I Atlas, even the simplest behaviors refused to follow the cosmic rulebook. Every step closer to the sun revealed a deeper contradiction, a stranger clue, a new anomaly. And all of this is leading scientists to one unavoidable conclusion. 3I Atlas isn't just an interstellar visitor, it's a messenger from a star system completely unlike our own. By the time 3I Atlas crossed into the inner solar system, its behavior had become so inconsistent that many astronomers admitted, publicly and privately, that they had never seen anything like it. And nothing showcased its unpredictability more than what happened next. The development of its tail. Every comet forms its tail when solar radiation pushes dust and gas away from its surface. It's one of the simplest, most reliable phenomena in planetary science. But when 3I Atlas formed its first tail, something was very wrong. It pointed toward the sun. At first, scientists thought it was an imaging error. Then they checked again, and again, and again. No mistake, no glitch. The early coma, rich in CO2, was being pushed toward the sun instead of away from it. The best explanation is that 3I Atlas began sublimating so early and at such a low temperature that the solar wind simply wasn't strong enough yet to shape the material into a proper tail. Instead, gas accumulated on the sunward side, creating the illusion of a backward-facing plume. It was another first in the history of astronomy, but as strange as this was, 3I Atlas was about to reveal something even more extraordinary. In early October, the object passed within 0.19 astronomical units of Mars, the closest approach it would make to any planet in our solar system. And, for the first time ever, we had the opportunity to observe an interstellar object, not from Earth, but from the surface and orbit of another world. NASA's Perseverance rover captured a faint but unmistakable streak of light cutting across the Martian sky. It took 30-second-long exposures, stacking image after image to create a single frame. Even then, the object appeared as a thin trail, blindingly bright but impossible to resolve in detail. From orbit, the ExoMars Trace Gas Orbiter captured a slightly sharper image. Still no visible nucleus, still no clarity on its true structure, but enough brightness to confirm that the coma was expanding rapidly. The one instrument that could have given us a groundbreaking close-up, the high-rise camera aboard the Mars Reconnaissance Orbiter, was offline due to a government shutdown. The timing couldn't have been worse. The best possible opportunity to photograph the surface of an interstellar visitor, lost to politics. And now, the object is gone, hidden behind the sun. A massive, ancient traveler, unreachable for weeks. But when it re-emerges in December, scientists believe we may finally see what the sun has done to it, how it melted, cracked, or transformed this alien relic. And the closer we get to that moment, the more one chilling question grows. What exactly is going to come out on the other side? Now that 3I Atlas has vanished behind the sun, astronomers have shifted their focus to an even bigger mystery. Where did this thing actually come from? Because nothing about its behavior, its chemistry, its trajectory, its polarization matches anything we've ever seen from known comets, asteroids, or interstellar debris. To find answers, scientists did something extraordinary. They traced the object's incoming path backward through time, calculating where it had been, not just months or years ago, but millions of years before it reached us. And that's where the story becomes almost unbelievable. Over the past decade, astronomers have used advanced simulations to reconstruct past motions of nearby stars. When they applied that same method to 3I Atlas, they discovered that over a period of 10 million years, the object would have passed relatively close, astronomically speaking, to 93 different stars. But here's the strange part. The closest encounter 3I Atlas had with any of those stars was 0.3 light-years away. That's 63,000 astronomical units, an enormous distance, meaning that during that entire 10 million year journey, the object never came anywhere close to another star's gravitational influence. It has spent eons drifting alone through empty, untouched space. And that solitude is a clue. Because while our solar system is a bustling neighborhood, full of planets, asteroids, moons, collisions, heat, and chaos, there are parts of the Milky Way where things are very different. But to understand this, we need to zoom out. way out. If you look at the Milky Way from above, you see bright spiral arms, dense with stars. Our sun lives in one of these arms, but from the side, you see something else, a thin, flat disk where most stars orbit, and a larger, thicker region above and below it, called the galactic thick disk. This thick disk is quiet, ancient, sparse. Objects here can drift for billions of years without ever experiencing a collision, a supernova shockwave, or the gravitational chaos that shapes younger planetary systems. And based on its trajectory, its velocity, and its extreme age, astronomers believe 3I Atlas likely originated here in this untouched region, which means this object could be 7 to 8 billion years old. Older than Earth, older than the Sun, older than most planets in our neighborhood. If true, 3I Atlas is a relic from a time before our solar system even existed. But as researchers continued to study its composition, things got even stranger. The object's coma was initially dominated by CO2, not water. It showed extreme negative polarization, something never before recorded. Its gases carried nickel without iron, breaking every rule of stellar chemistry. And then, suddenly, water vapor began pouring out of it at a rate far higher than expected, as though a frozen interior had cracked open under stress. This combination suggests a history unlike any comet we know. Perhaps 3I Atlas formed in a star system where water ice was rare, replaced by exotic ices and metals. Perhaps it spent billions of years accumulating strange materials as it drifted through interstellar space. Or perhaps it endured powerful cosmic radiation, altering its surface chemistry in ways we can barely imagine. But there's another possibility, one scientists don't like to discuss out loud. Some researchers have quietly suggested that interstellar objects may carry signatures of catastrophic events, the shredded remains of ancient moons, planets, or even artificial structures destroyed long before humans existed. Is 3I Atlas one of these? A shattered fragment from an ancient world in a star system older than Earth itself? We don't know, but every new piece of data raises more questions. Even its trajectory challenges conventional wisdom. Oumuamua and Borisov, the first two interstellar visitors, approached from above and from a diagonal path, perfectly reasonable for objects drifting through random three-dimensional space. But 3I Atlas arrived on a near-perfect planar trajectory, tilted only 3 degrees off the ecliptic, as if it were aiming directly for the solar system's planetary disk. A 3-dimensional object from deep space entering a 2-degree-wide cosmic highway? That's not impossible, but it's statistically extremely unlikely. And yet, that is exactly what 3I Atlas did. Then there's the speed. Much faster than Oumuamua, much faster than Borisov, fast enough to escape the sun's gravity entirely, even before it reached the inner solar system. Taken together, these clues paint a picture that is both thrilling and deeply unsettling. 3I Atlas is not just an interstellar visitor, it is an anomaly, chemically, structurally, dynamically, and historically. A traveler from a place where the rules are different. And now, as it circles the sun, the real question is no longer, where did it come from, but something far more urgent. What will it become after surviving the sun's heat? And what will we discover when it finally reappears? Right now, 3I Atlas is hidden behind the sun, out of sight, unreachable, and impossible to study. For the first time since its discovery, humanity has no direct view of this interstellar visitor, and that silence has left astronomers with a single burning question. What will 3I Atlas look like when it emerges on the other side? Because perihelion, the moment of closest approach to the sun, is not just a point on a map. It's a crucible, a test, a trial by fire. Anything that passes through this region is transformed by it. And for an object as strange and volatile as 3I Atlas, the transformation could be dramatic. As it skimmed past 1.4 astronomical units, the object reached temperatures that would fracture rock, vaporize ice, and expose hidden layers that have been sealed for billions of years. This is the first time 3I Atlas has encountered a star up close in eons, and some scientists believe the stress could split it apart. Others think the sun's heat may reveal entirely new materials beneath the surface, exposing the true nature of the interstellar traveler. Nickel-rich layers, iron-poor cores, exotic minerals formed in ancient star systems, or something we haven't even imagined yet. And we won't know the truth until December 19th, the date when 3I Atlas will once again be within view, making its closest observable pass to Earth. But the surprises don't stop there. In March 2026, 3I Atlas will have one final encounter before leaving the solar system forever. A close pass by Jupiter at just 0.36 astronomical units. Jupiter's immense gravity could distort the object's path, compress its tail, or even trigger new activity as the interstellar debris interacts with charged particles around the gas giant. And watching all of this will be NASA's Juno spacecraft, offering us one last chance, perhaps the only chance, to capture a detailed image before 3I Atlas vanishes into deep space. After that, it's gone. A one-time visitor, a cosmic messenger slipping back into the darkness between the stars. But here's the real mystery. Every time we think we understand this object, it contradicts us. Every time we assume it will behave like a normal comet, it shifts into something stranger. And every new observation raises the possibility that 3I Atlas is not just unusual, but unique. A relic from a star system older than ours. A survivor of ancient cosmic catastrophes. A frozen archive of chemistry and physics we've never seen before. Or perhaps something even more extraordinary. Because if 3I Atlas truly formed in a region where the rules are different, where the elements combine differently, where temperatures are lower, where collisions are rare, then this object is more than a comet. It is a time capsule from an era predating our own solar system, and the fact that it is here, now, passing through our tiny corner of the galaxy, is a cosmic coincidence so unlikely that some scientists have begun asking a dangerous question. Was this simply a random flyby? Or are interstellar objects like 3I Atlas far more common than we ever realized? What we learn in the coming months may reshape our understanding of planetary science, interstellar chemistry, and even the formation of galaxies. But until the sun releases its grip, all we can do is wait. If you want to follow every update, every image, and every discovery about 3I Atlas as it re-emerges from behind the sun, make sure you like this video, subscribe, and turn on notifications, because the next time 3I Atlas appears, we may finally uncover the truth about what's really traveling through our solar system right now.